Sounds good.
Yeah, what are we going to do tonight?
We're gonna play with some installed stuff on my local machine. I am running Ollama in a container. Ollama is a website and a system for running LLMs locally. And I have it running in a Docker container. I'm not going to go into the details of the Docker container unless you guys are really interested, but essentially it's an isolated environment on my machine. Okay. I have a few models installed and I will show you how to list that. And we're going to use some command line tools, including curl for retrieving, for doing HTTP requests, and JQ for formatting JSON or digging through JSON. So
Let me ask a question.
sure, and anybody please welcome to interrupt anytime. We can go
Why
as fast or as slow.
why does one wish to do this?
Why does one wish to do this? What I think is valuable here is understanding how the models are actually interacted with at the API level, and in particular,
Oh, no,
understanding.
back from there. The, I think that the answer that I was looking for is one wants to interact with an artificial intelligence model. That's why you set this up.
Well, I think that the valuable takeaways here is how the models themselves work, how smart or stupid they are, where does their memory come from, how do they go about using tools, what is an agent versus a model. Um, and I think separating those concepts is not trivial. It took me a while to understand that. And I think if you're curious, you might get a better idea at the end of this presentation. Does that make sense?
Yeah. One of the things that I'd like to comment, though, on your very first bullet point in lesson 0,
Mm-hmm.
I had to look this up myself recently because I use Ollama and LM Studio, and I was trying to say, and I'm using VS Code development environment, and I
Uh-huh.
have a bunch of models. And so I wanted to know what function does Ollama and LM Studio perform relative to the model file.
Well,
And the answer that I got back from artificial intelligence was Ollama is an inference engine. The model file itself is not anything that it's not a program. It's just a pile of data. And you need something that understands how to work with that data. And
well,
Ollama is the thing that knows how to work with the model files.
Ollama is a model runtime. It is also a model manager. So there are several layers, and it's also an API server, right?
Oh,
So
so okay,
So
so
among other things, Ollama allows you to choose models, install models locally, run them, activate them, and it also provides an HTTP server that we can make these APIs queries to. So there's really a combination, several layers that Ollama itself provides.
thank you for letting me comment.
Um,
You're
all
on.
the time. So should I assume that anybody's familiar with curl and JQ, or do we need a short intro in that direction? How about we go there? I've got some cheats. So if I run this command, yep, it returns me a chunk of HTML. www.example.com is just a site out there that serves example HTML. And as you can see, that what I got back was an HTML jumble it's not formatted, only your browser knows how to format it, or we can maybe use a command line tool to format that and see maybe slightly better output. So if you're familiar with HTML, then this should probably make sense to you. And if you're not, it's a really simple format that allows you to embed some formatting directives, such as a header here and some text here. And that's all. And if, let's see.
So let me interrupt you again one time.
Please.
Even though this is a Linux meeting, Curl works on Windows as well and Mac, right?
Yep.
And I don't know whether XML lint does, but probably there's something equivalent to be able to do exactly this if you're on Windows.
Well, XML lint is an HTML formatter. I mean, another popular HTML formatter is called a web browser, right? So we can take this URL, for example, and just open it in a web browser, and it gives you an actual formatted document. And if we click on this and say view page source, we get to see pretty much what we got from curl. Does that make sense?
Yeah.
All right. So what else do we have? Curl is not HTML sensitive in any particular way. You can retrieve, for example, text. Here's a website that gives you your IP address. If I tell curl that I only want to use IPv4, it will give me my IPv4 address instead of IPv6, which is what we saw earlier. So that kind of stuff. Another thing that you can get from some sites is something called JSON, which is a structured data format. Here is an example, right? And JSON is just a very simple text-based data format. This particular site happens to format the JSON in a readable way. There is a tool called JQ that can much of the time your JSON output will come unformatted like this, what you see at the bottom of this. I can actually suppress the statistics output from curl with a -s to tell it to be silent. So this is typically what you might get. And if you wanted to format the JQ output in a readable way, you can just pipe it to JQ and it'll produce that. And if I tell JQ to, for example, just pull out the .origin from that message, it will give me just that. So that's kind of curl and JQ in a nutshell. Is there any curiosity, any questions? Should I show more about curl or JQ or any of those?
Not from me.
All right. Then we can move on to the real stuff. Lesson 1. LLMs, all they do is they take a prompt and a piece of text and show you a response. So we're going to shove that right in here. And just a couple of seconds later, since the model is running locally in my NVIDIA GPU, it does take a few seconds to respond, and you'll actually see why.
I'm going to interrupt you.
Please.
You have Ollama running as a server on your machine.
Mm-hmm.
And that's why you're sending this message to localhost port 11434.
Yep.
That's where Ollama is.
That's where Ollama is listening. And actually, Ollama happens to be in a container, and the container's port 11434 is mapped to the host the same way. So that's why I can access it from the host.
So you were talking to some particular model that you told Ollama to be.
I told Ollama right here to talk to a model called Gemma 3. And then I gave it a prompt of why is the sky blue? And then I told it to just spit out the response as a whole chunk instead of spitting it out as it's being generated. And we'll see why it's tedious to have it stream the response. It's very nice for interactive user interfaces because you can see response as it's being composed. It's really not very helpful with an interface like this, where there isn't something on the front end that knows how to format the bits as they come across. And then I use JQ to pull out the response field. And we'll see why in just a second. There's a whole lot more than that just one response field that's coming back, but we'll get there in a second.
Well, do you have the Ollama GUI up also?
There is no such thing as an Ollama GUI.
Oh, on Windows there is.
Okay. There are many, many, many GUIs, and you can create one very easily. And I sent one out with the original message, and I'll show you how it works sort of towards the end of this, because a GUI is really only about how the model or the runner interacts with the user, and not about how the model itself works, which is kind of primary focus here. So as you can see, here in the terminal, what was generated was a fairly long response. And maybe just to keep things slightly more manageable, we can say answer briefly. There. Now it's a shorter response, but it's being helpful in asking us for a more detailed explanation.
Hey,
by the way, yeah.
Okay, now you're going against your local model, your local Ollama model.
Yep.
Your local Ollama using a model of Gemma 3.
Yep.
Okay. Where did all that data come from?
I had Ollama pull it down. I gave Ollama a command that is literally Ollama pull Gemma 3.
Okay.
And it pulled it down and saved it locally.
Okay, so when they talk about a local LLM, it's not where you're using your own data.
No, I did not. Yeah, I didn't create that model. I didn't define it. I could do some tuning on it because Ollama has some ways of tuning things. If you actually search for Ollama API reference, there's all kinds of information available.
I haven't gotten to the point where I could spell API. I'm just watching. Go ahead.
No problems.
So there's a distinction here about local. What do we mean by local? If there's an instance of Gemma 3 that lives on some server in the world, Gemma 3 is from Google, right?
Correct. I believe you're right on that.
And so if you go to some Google website, you can interact with an instance of Gemma 3 that lives.
I don't know that Google actually offers a public web-based interface to Gemma 3, but could be.
But Google offers one to Gemini.
Sure. And
they put their best model out there. So you can interact with that. But as I said earlier, if I'll say it again, that the model file that you download from somewhere, and you might get it from Hugging Face or Civitas, I think is another name, and you put it on your machine. So Gemma 3 might be 10 gigabytes. I don't know off the top of my head.
It's significantly smaller than that. It's about 4.
4 gigabytes?
Let's see. It is just under 4 gigabytes, including the Ollama runtime, as you can see down here.
Okay, so you bring down this data file, which has been trained to do certain things, and you put it on your machine. Now it's on your machine, not somebody else's place in the cloud. And you put Ollama on your machine. So you can talk to that AI model, large language model, on your machine. And you can feed it your data on your machine. And it doesn't go out to the internet. Nobody else sees it.
You do.
That's local.
Oh.
When you say data, you mean your documents or whatever you're giving to the model to answer your question, right?
Yes.
We're going to dig in there, but the model does not have any local storage of its own. Everything that you give it comes to the model as part of what you are handing it at the time. Now, the model may, the runtime for the model, such as Ollama, may actually cache some stuff and make it readily available, but that's the option. I'm not aware of Ollama in particular having a document store where it can cache things. But some other runners absolutely certainly do. Like ones for some of the professional models, such as OpenAI or Claude. So,
yeah, I think when John was talking about data, I meant along with the prompt, you would pass in some data to say, okay, hey, take this data and answer my question about it. That's all sent to the model, and then that's the end of it, right? It's we get the response, and that's the end of it.
Yep.
Well,
You're saying nothing persisted between requests.
Here again is where we make the distinction. You're interacting with a data file, which is static. The Gemma 3 data file that's 4 gigabytes is static. It doesn't change.
That absolutely has no way of changing.
Ollama is an inference engine that uses the numbers of the matrix that's in the data file to answer the question.
I would be careful with the term inference engine. That is a much broader concept and usually is not associated with large language models.
Well, that's in fact what a large language model said that Ollama is.
Okay.
That it uses the data. And if you switch out Gemma 3 for Gemma 4 or QWEN 2.5 or something else, like it will use other values for the model, but the model doesn't change.
Correct.
Now, do you have a graphics card with VRAM?
That's what we were just looking at.
Yeah, because you did the NVIDIA, what's SDI, SMI? Yeah. Mm-hmm. So right now, Ollama is loading the model into VRAM and executing it there because the VRAM is faster for that. I don't know what would happen on a machine that had no VRAM, video RAM, and a graphics system.
Ollama understands how to use the GPU or the CPU. Notice that right at the moment, actually, that model is not loaded into the GPU. It's only using 837 megabytes out of the 12 gig available, and none of the processes listed here are Ollama. But Ollama does multiple levels of caching, so next time that I use a query like this, it will cache it in RAM and then very quickly load it into the GPU. So now you can see that it was very quickly loaded and allocated and loaded into the GPU. If I were to reboot the machine, for example, where the model would not be cached in RAM, it would take at least a couple of minutes to, or close to a couple of minutes maybe, to load the whole model from disk into RAM and then from RAM into the GPU.
Okay, so just going back to Andy's question to make this clear, what it means to run the AI locally is that you brought a model file, in this case Gemma 3, onto your machine. You have a program that can interact with that model file, in this case Ollama, and you can interact with Ollama. And the way Sergey is doing it, he's using curl to interact with Ollama, which presents a port, is available on a port on your local machine. So all of that is local. So if you hand some local data, personal data, through curl in this way of doing it, and ask the model to do something with it, it can operate on it, and nothing. You don't have to be connected to the internet at all.
That's correct. This is all local. So if you look at the Ollama PS command that I just issued to the Ollama running in the container, it says that it's going to keep that model in the GPU for next 4 minutes. So it actually has a way of timing these out and unloading them from the GPU. So it's still there, but it's only gonna be there for a couple of more minutes. 2 minutes. Unless of course we send another request to the model. And let's go ahead and do that. So the next thing to see is that the response is not just the actual response text, which is what we saw earlier by extracting the dot response element from the data that came back. There's a little more than that. Oh, I forgot to use the brief version, so it's taking its time to generate a lot of output. So it's generating this whole pile of numerical output. Let's optimize this a little. First of all, let's forget the JQ for now. And let's say answer briefly. And so there's our brief response, and notice that there is a whole bunch of numerical data coming back as context, which is an internal representation of something that can be sent back to the model. But I'm actually going to say, hey, I don't want that context. Show me the good stuff.
Thank you.
So there is the complete response, other than all those numbers in the context that we have no way to interpret at the moment. So notice that there's some evaluation duration in microseconds, or yeah, microseconds probably. No, maybe nanoseconds. And evaluation counts and all kinds of additional statistics, whether it's done or whether this is a partial response. The actual response text, which we earlier extracted with a dot response. Right? All right. So it was very convenient to extract the answer in this way right here. So there's lots and lots of metadata that comes back with each request. Now let's talk about memory. So I'm going to say, hey, my favorite color is blue. What's my favorite color? And of course, it brilliantly answers that my favorite color is blue, because I just told it that. Now, if I don't give it a hint, but instead just ask what is my favorite color without giving it that information up front, as we discussed it, It has no way of knowing. It has no memory. The model is completely isolated from any data at its default runtime. Right? And unless that data is somehow supplied to the model through the model runner to the model does not have any knowledge other than what was trained into it. So we can try to kind of fake that. Notice we kind of gave it a previously known information tagged as the user, and then gave it an assistant : prompt, essentially prompting it to fill it in. And of course, we get a brilliant response that it really likes my choice of color blue.
So what did you do here again?
So in the prompt, I said, the user previously told you that the color is blue, and then prompted it to continue in the assistant role.
So that's a keyword, assistant and user.
Many models will understand this and will follow the prompt structure to produce a result. There are other ways to give the model and the model the same structure. In this case, this is fully going directly to the model. There's nothing that the runtime was filling in here. Right?
Now, if anybody has been using Copilot or something else, like I use Copilot on my phone and on my Windows computer, and I'm logged in to both of those, and Copilot remembers what I told it, and it answers everything in the context of stuff like that.
There's a wide variety of ways of providing context to the model, but at the API level, it's kind of a very narrow set of options.
So somebody built something called Copilot that
holds and provides
that.
this context.
And Gemini, if you use Gemini.com, for example, or probably the Gemini app, and you log in so that it relates to your login, the stuff that you've told it, it will remember it unless you tell it, we're going to do something new here, forget everything else I told you, and only work with this information.
Notice that we're using a very simple generate API, which is designed to be used for one-shot prompts. That is a prompt and a response. If you want a more coherent conversation type response, there are other APIs that can be used, and we'll look at those. As a matter of fact, we're going to look at one now. So chat is another API, and it's actually designed to help the model understand a sequence of messages. So this is almost identically exactly the same thing that we did last time. The only thing is, instead of handing it one prompt with the fields user and assistant built into the prompt, we're handing it a message with a past conversation from the role user that says, hey, here's that. And what we get in a response is a structured answer, and the assistant tells us, oh, your favorite color is blue. Does this make sense?
Yeah.
So it's the same kind of idea. It's just structured differently.
So again, just going back to that. So then is it, when you do a follow-up message, you have to pass in that assistant message back into it, correct?
It's nice that you asked.
Sorry, I jumped ahead. Yeah.
Because here is exactly an example that shows that. Right?
So basically, as a as a as a consumer of this, you're supposed to save that response that you got from the first invocation and sort of append it to the next message in that sequence, right? As long as you want to maintain a sequence.
And that's exactly what your clients do, whether they're web-based or terminal-based or anything else.
And that's what
Right.
probably what Copilot does too. It's just
Yep.
keeping a track of all the prior assistant messages and sending them back.
That's right. So that implies that the size of the conversation grows with each following prompt,
Correct.
right? And that is why eventually you can run into context limits,
Yeah.
where it starts either compressing the contexts or forgetting older parts of the conversation. And that's why sometimes when you interact with a web-based, chat-based agent, it appears that it forgets things that you told it previously, or its memory weakens. Right? So there you go. We've continued that conversation from the previous 3 requests or responses to our 4th one. Right? So now we've got 2 pairs of user assistant requests responses. Right? So in addition to this, there are other ways of providing instructions to the model. There's always something called a system prompt, which usually by the way that the models are trained takes priority over what the user asks for. So for example, I could change this system prompt to say, oh, how about answer poetically? And I get a nice poem back.
I noticed that it handled the misspelling of poetically.
Oh, yeah, they're pretty smart about that. And that's one of the big advantages of LLMs over your typical search engines, where sometimes they'll correct your spelling and sometimes they'll misunderstand you. There you go. It felt that it should helpfully provide me a translation since I gave the prompts in English.
I was going to say the responses are coming back pretty fast. That's nice.
Oh yeah, if you notice, the original early responses about the sky being blue were very long comparatively, and that took longer. And it's because it takes time to cycle through the generation of a longer text, right? The short responses will come back very quickly. So let's see that. So that was still fairly quick. But maybe you noticed that it took slightly longer. We could probably examine the size of the response if you want to go there, or maybe we can come back to that later if there is interest. So maybe we should keep plowing through. There is all kinds of other things that you can influence: the length, the tone. I mean, you can literally go and, you know, do silly things like, you know, And I'm sure that it will also answer in many, many, many languages. It is shocking how much expertise is trained into these models as far as language knowledge and nuances. Another way of exploring that capability is, for example, so you have a tremendous amount of control of steering the model, but if you don't supply any specific directives, then it will choose whatever its defaults are, whatever it's trained to be the default.
Yeah, I think I remember reading somewhere that the original sort of idea for the GPT models actually came from the way the Google Translate model was written. So that is really the original model, so to speak, that Google created in Google Translate, and then that's why all that information was baked in already.
Makes sense. All right. We're going to do some experiments to try to play with the structure and all kinds of things like that. So this might be a baseline. And this kind of repeats what we've already done in the past. And notice that this is taking longer, and it's probably likely to generate a fairly long answer. Okay. Notice that it's got some resource quotes. And also notice that we asked this question before and got a different answer. It's not exactly the same, though it probably covers some of the same points.
Does it support the temperature tag?
Well, it's interesting that you ask. We're going to go there in just a few minutes.
All right. Sergey didn't pay me to say all this, I can tell you that.
So, we've already seen some examples of this, but at the risk of being repetitive, I'll repeat this experiment. And so that you can limit the output in all kinds of various ways, whether as part of the prompt, as part of the system prompt, or in some other way.
Sergey, you're passing the word generate or chat to Ollama. That's part of what Ollama gets. So
I'm not sure I understand what you're asking. You said that
in the curl command,
yep.
You're sending the word generate to the Ollama API.
That's the API endpoint. So this is part of the actual URL that determines the function that Ollama performs. So
Ollama is performing the function.
Ollama, I am calling a very specific function in Ollama. So
and this is the documentation of the Ollama API.
So here is the documentation for the generate API.
Could you make it a little bit bigger for a while?
Sure.
Thanks.
So that's the documentation for the generate API. And as you can see, there's multiple parameters, and I'm not supplying all of them. So just was asking about temperature. That's one of the options. But there's explanation of streaming. This is actually the documentation for Ollama API is really very readable. So I would, if you have curiosity about how this stuff works, I'd recommend it. And here's a different API. It's a chat API that is designed to hold multiple messages in a conversation. Right? And there's other APIs, including creating a model and listing models and pulling a model that you asked about earlier, and you can actually push a model back. I haven't tried that.
Does Ollama support anything about images?
That's not about Ollama. That's about the model itself. And we'll look at that. We're not going to play with images directly, but we will explore how to find out which model understands concepts of images. If you would like to play with image manipulation, maybe we can do that some other time. But I think it's slightly more complex than here. So here's an example of prompting and including a specific formatting directive in the response. So I'm asking it to respond as JSON with specific fields, and let's see if it feels like doing that. Well, looks like it did. So that is something that is really up to the model as to whether it produces syntactically valid JSON. They do tend to do that, but it's not absolutely mandatory. Models are somewhat non-deterministic, and so you're giving a very, very precise, exact request to a model that knows how to generate approximate data. So there are some things that these models are very, very bad at.
But
For example,
it looks like correct JSON though.
Yep, this one looks like perfectly well. We can verify whether that's correct JSON.
It has the two fields that you asked for, and it's
Yep, certainly does. I don't see any issues with this JSON.
I mean, it did the extra part of adding the markdown JSON indicator, which is nice.
Yeah.
The response is actually in text, so it's going to combine the two.
Oh, that's what I want. Yeah, I already lost that. Let's see, is that gonna... Yeah, I think that stripped the leading yeah, okay. Now I can just pipe that response to JQ and validate whether it's actual valid JSON. Oh, it didn't like that. I wonder why. Oh, it's the word JSON. Now that's interesting. All right. Obviously, I can't just synthesize that.
Can you? Oh, I don't know what you're going to do next, but can you ask it to generate a short bash script that says hello world and pipe it to bash?
Well, I don't know that this particular model is very good at it, but a bash script that does what?
Just types out hello world
Oh,
and the date.
how's that?
Yeah. And then pipe it directly to bash.
Well, let's see what it generates.
Oh, what does it say?
It generated a whole bunch of other helpful stuff. And of course, it still framed it. And it forgot, oh, I see. And it output the date as a separate statement. There you go. That works.
But you say this model is not really tuned for code generation. It's just, this is a simple example, so it can go into like props.
Yep. Well, let's see.
$100?
There you go. So it does a fairly stupid test for primality, as you can see, but it generated the script. Does that help? Does that answer the question?
Oh, yeah, I see what Gemma 3 is putting out. It's putting out this stuff that has the
Oh, you're not
triple quotes before.
you're not a Python programmer. Okay, sorry. Do you prefer it in C?
No, I just wanted something that you could pipe directly to the program that's going to execute it.
That's really a matter of handling the output in the shell. So, you know, I can try. Let's see if that does the trick. Yeah, that looks like it did the trick. There you go. There's your first 100 primes. So if you want me to explain the Perl bit, I can.
No, the point is that one might not want to have to know Python or Perl, but only how you would do things in Linux command line to be able to get the answer you want.
Well, you could certainly get the same result without the Perl bit. I happen to find Perl very convenient, but you could use sed or awk or something else to filter out the extra framing that was output.
Oh, right. Yeah.
Right.
Get rid of
That's all the Perl does. Perl just says print every line and substitute anything that starts with a back quote with all the way to the end of the line with nothing.
I understand.
So that's where we got this blank line from. It removed these quotes.
So once you've got this thing at the front of the curl setup, once you've installed Ollama and brought down a model, you can use the model locally like this.
There's all kinds of ways to use that model. I mean, Ollama has a command line user interface that you could use. If you wanted to script it, this is probably the best way.
Well, this also means that you could include this request for information into a program
Absolutely.
or into a shell script to get the answer from AI built into your program.
Absolutely. That's how every program that has AI capabilities work. They just talk to some API somewhere.
And perhaps you mentioned this earlier, Sergey, but I think that the API surface that we're looking at is identical to what the public OpenAI and Gemma APIs are, right?
Not quite. Interestingly enough, Ollama actually provides two different sets of APIs. Ollama provides an OpenAI-compatible API as well as its own private API. We're looking at the private API. The OpenAI-compatible API is very much there and it's very much available. One of the things to do with that is to make one of these local models look like an OpenAI model and hook it up to some other tool, such as, for example, Codex or something else.
Yeah, because
I've yet to experiment with that. It's on my list.
the OpenAI interface differs from the Anthropic Claude interface.
They are slightly different. There is a whole lot of parallelism between them, as I understand. I have not studied all the APIs in detail. I've mostly played with this one. I've looked at OpenAI API briefly, and it's very, very, very compatible. That is, it's very easy to translate between APIs. OpenAI API includes a whole lot of other things that are not available from Ollama, such as, for example, local file storage, uploading files, manipulating things that are just not in the Ollama environment, but are in, manipulating accounts, manipulating user settings, all kinds of things like that. But let's go back to the plan here. And one of the options that you can hand to a model is something called temperature. And temperature controls how randomized the model response is. That is, how widely does it examine all available possible answers to select what it's going to produce. If you give a temperature of 0, it is going to give you absolutely the same response every time. So here's 2 requests, and as you can see, we got responses that look very much the same, or at least very close to each other. If we change the temperature to, let's say, something like 3, we might get a slightly different response. And if we crank the temperature up to, let's say, 10, we might get something that is completely silly. As you can see, this just makes lots of pieces in this just make no sense whatsoever. And that's because normally you would want to keep your temperature relatively close to 0. Typically, it's between 0 and 1 is considered normal, but it's actually model specific. So, for example, if I were to, instead of Gemma 3, use Gemma 4, let's start with a 0 and see what the base response from Gemma 4 is. This will take a couple more seconds because it has to load Gemma 4 into memory, into the GPU. It's in memory from prior exercises that I was doing. So as you can see, this is kind of a different response in character. If I do something like a 3, it gets something else that's slightly more random or creative. Let's do another one at the same temperature just to see if there is how much variation we'll see. So as you can see, there's a fair amount of variation. But the point is that temperature is specific to individual models, even though generally 0 is likely to give you very consistent responses, and going above 1 is going to trigger various levels of quote unquote creativity / hallucination. So that was the point of this exercise. Any questions? By the way, temperature can be a floating point number, so you don't have to operate in even clicks. Did this make sense?
Yeah.
Okay.
Actually, one of the things we do when we use the temperature in our applications is that we don't use a number 0. We use a very small number instead, 0.001 or something like that. It seems to work better. I don't know why.
Makes sense. So how about if we ask it for some real information? So just in case you're not reading as fast as I am, the prompt here is, what is the current temperature in Tokyo? And it tells me that on November 3rd, 2023, the current temperature is 18 degrees Celsius, which may be very relevant, but it's not right now. And if we ask, so it essentially fantasized their response because it didn't have anything else, but it also wasn't admitting it that it couldn't get the current information.
Well, but that's not a incorrect response though.
It is absolutely. I asked, what is the temperature right now?
Yeah. But I'm saying that the value that it provided is actually
may have been factual value trained in.
Yeah.
Notice that Gemma 4 gives a completely different answer, and it tells me that, hey, you can go somewhere else. It cannot do that right now.
So we know that Gemma 3 was trained somewhere in November 2022, basically.
Yeah, Gemma 3 was just fantasizing something that it thought was relevant. So how do we get the model to actually use a tool? That's the question. And the way that we do that is by giving it a tool. In particular, we give it a type of tool, which is, today it's always function. And then there's a description of the function, what kind of parameters it takes, which ones are required, and so forth. So if we do this for Gemma 3, it says, oh, I'm Gemma 3. I don't know how to support tools. And actually, if we ask Ollama about Gemma 3, Ollama will tell me that it has capabilities of completion and a vision, but not tool usage. On the other hand, if we ask Ollama about Gemma 4, it will tell you that in addition to those capabilities, it also has audio and tools and something called thinking, which means that it can produce intermediate output that shows its train of thought, right? So this means that we probably, if we want to show how to use tools with these models, we should probably switch to a tool-capable model, specifically Gemma 4. Yeah, there's some of that right in here. So you can look at the cheat notes that I send out several days, I guess a few days ago, last week. So we're just going to do exactly the same thing with Gemma 4, and we're just going to start over. We're going to ask Gemma 4 what it thinks about the temperature in Tokyo. Oh, we already did that, right? So let's go ahead and give it a tool definition and see how it responds. Let's go back to the window where we were doing all of our curl interaction. So I'll let you stare at this for a second. Still asking what is the current temperature in Tokyo, but this time we're providing a tool. A tool is a function, and the function has a name of get weather, and a description, and a definition of parameters. So now what we got back is a piece of JSON that says assistant is calling a tool. Here's a call ID, a unique one just for tracking the call. And it wants me to call the function get weather, and it wants to get the weather for Tokyo. So it's following my definition of the tool to ask me to call the tool on its behalf. And if I pretend to be that tool and provide the tool output back to the model, I'll paste this in and then we'll look at it. So the prompt is still, what is the current temperature in Tokyo? Right? But now the tool down here provided the answer, and the content of the answer is JSON with some escape characters, but the information that's in the answer is cities, Tokyo, and temperature is 28, and the unit is degrees of Celsius, and the condition is clear. And now that we provide this tool output back to the assistant will capably notice the thinking output also. So it built a strategy for calling the tool, getting a response, and then integrating that response into the answer. So this is the essentials of how tool calling works. Questions?
Can it call the
Why is
tool?
Why is it showing the thinking though? Shouldn't it give me the final formatted answer?
The final formatting answer is the content.
Oh, I missed it. Okay, that's what it is. Yeah.
Right?
Yep.
And the thinking was supplied
To show you how it got
as additional data that my user interface may or may not want to display.
there. Yeah.
Right?
It's the citation basically.
Yep.
That's nice.
So I found this fascinating and insightful. Essentially, your client, your user interface is what routes these intermediate tool calling answers to the actual tools that it may be embedded or that your user interface knows how to call. And it handles that interaction invisibly to you as the user. So for example, if you ask a chat agent, a web-based chat agent, to go look at a particular website or research something carefully, it will go out on the internet and make those calls, and it's because it's been internally defined with these tools to have that capability. Right? It knows how to go fetch web pages, among other things. So that's kind of the life cycle of tool calling.
Could you ask Gemma 4 what the structure of a large language model file is?
You could probably ask a chat agent, any chat agent. There is a tremendous amount of information, and we'll actually touch on some of that immediately in the next section. Because I think we're done with the main part of the presentation that kind of has a very bounded idea of helping you understand how the model interacts with the user interface and what kind of things are built into the model and what kind of things are not. what kind of things are provided by the surrounding infrastructure.
So if you were using one that was not local, as we've described, you would be putting your personal information into the message box that gets sent through the web page that you're interacting with out to somebody else's Ollama instance or whatever. But that's where your information is no longer private because it's being sent out to a website.
I mean, various companies will make various guarantees on how whether they use the information for further training, whether they retain it. They may have legal obligations to retain it. There's all kinds of considerations that they have to deal with specifically because they're making these services available. And there is a tremendous amount of noise going on around ongoing legislation where legislators are trying to protect people and at the same time not cripple the industry. I recently saw an item on the news that I think Illinois joined New York and California in enacting legislation that specifically outlines responsibilities, including reporting responsibilities of these companies that are providing access to these models, specifically to mitigate risks. And there's fascinating stuff, very difficult. These legislators are obviously not experts in large language models or AI, so it is very easy for them to make demands that may or may not turn out to be practical. There's a tremendous amount of interaction and traffic and noise around that. Good luck figuring it out, but it's also fascinating. I said I do recommend looking at the news for that and taking a look. So here's an API called tags, which just lists the models that I currently have available, right? So for each model, it lists the size and what kind of format the thing is in, and the parameter size, the quantization level, and so on and so forth. So it lists some of the information in some of these models. And of course, we can use the magic of JQ to, for example, go .models.name to list just the names of the models. And if we wanted to be careful about it and remove the extra quotes, we could do that. -R to JQ says, give me the raw output.
So those are the models that you currently have
Correct.
loaded on your machine that Ollama could use.
That's right. Notice that I do have some coder models, both a 14B and a 7B variant. I didn't find a horrendous amount of difference between those two, even though one is twice as large as the other, but interesting. And to be fair, there's no real way for me to fully evaluate how capable of a coding model is. But there's all kinds of statistics and tests out there.
There's a benchmark for that, yeah.
And published stuff. So here's, well, maybe I should do this one next. And so we can get information about an individual model. And I'm actually going to output the whole thing. And if you look at this, you'll notice that there's a tremendous amount of information that's output about the various model, just sizing parameters of various model layers. This is obviously not a full description of the model. This is just the sizes of some of the layers in the model.
So when you say layers, like at any point you have for example, I see a Q4_K.
Mm-hmm.
And if it uses just one of these layers, it's not so big, like And those other numbers are,
or the shape of the layer, whether it's a linear that is a vector, or whether it's, for example, in this case, in the case of these weights, it's a 2560 by 10240 matrix. Q4K is a 4-bit integer encoding. F32 is actually a 32-bit floating point encoding. So each layer could be encoded differently. And you can see different quantization levels. How that's tuned, that's outside of my pay grade. But notice that there is a whole lot of these. I am scrolling and scrolling and scrolling and scrolling. We'll get to the end eventually.
but
Or maybe not.
what I understand about this is that data in the model file is the code numbers, and the code numbers could be bigger or smaller, and that's what the quantization is.
Quantization is just a way of each individual weight within each individual object, whether vector or matrix, is represented. Notice that there's a license text that's included that's fairly long and detailed. We can look at that if you wish. There is a model file component included. We can dig through that. There's a template included, and we can dig through that as well.
So this is the thing that I asked about.
The actual weights, they're not listed here. There are billions of them.
Which is what, the 7B or 14B or that is?
This is a particular, so the actual element that holds all of these is tensors. And there's a whole bunch of them, right? So maybe we can say, I do have to spell it correctly. This is not an LLM. No, maybe not. About over 850. Oh, 882 of them. I guess I should have picked that up from here. So large chunk. Let's see, what else can we find? Let's just find out what the top level keys are in this output. So there's capabilities, details, license, model info. So we saw this before, right? There's the model info, and as you can see, it's just a collection of all kinds of numerical parameters or Boolean values about the model itself. All Greek. Most of it is Greek to me.
There should be an entry for the model architecture. Is that a model info?
A model architecture?
Yeah.
What is a value for the model architecture?
There is
a word that would come back, Sergey, Sujit, if you asked it for that. So we can search for that word.
That's a good question. I'm not sure what, but the way that I understand is that each of these models, they belong to a different model family, I think, or architecture family is what they call it, right? Because the weights and biases, which is what Sergey was just displaying, they have to be processed in a particular way as it's inferred through the neural network. It's a multi-layer neural network, and it applies, those sigmoid functions or various algebraic functions as it goes along to figure out what the end result is. But the architecture that they go through, in other words, whether they do things like, an attention block followed with a sigmoid function or something different, is determined by the architecture model, right? And there's a few different architecture models, and in fact, Ollama will load the correct architecture model for a particular model. So, in other words, the pipeline that it runs through that model will be different, two different models. Possibly Gemma 3 and 4 may have the same, but others may be different.
I remember seeing something like this.
Yeah, it should be like I think
Yeah.
I think Quinn has their own, Gemma has their own, Phi has, the Phi from Microsoft has its own, DeepSeek has their own. So it's kind of somewhat related to the provider.
Well, some of it is obviously encoded in the details.
Yeah.
But and in the parameters and in the
I think you have the family Gemma 3 there right there. So that's good.
Yep.
So
it's a lot of stuff that I can only guess at this point.
But basically what that's determining is the code pipeline that Ollama will take for that model. Ollama can load different processing pipelines. It's not just one pipeline for all models, right? Models have their own pipeline. And
Well,
so,
I remember there being parameters that show how many heads it has and all kinds of things like that, and I don't know where.
I just asked Copilot, and it says the architecture is usually stored under keys like architecture, model underscore type, ARCH, or backend, depending on the platform.
there it is, general data architecture. I see right in the middle.
Well, this is not very descriptive, right? Yeah, there is some of the key parameters, the head counts and the KV lengths and key lengths and window lengths and things like that.
Yeah, but this is
Context lengths, the embedding lengths, the 2560 that we saw all over the place is essentially driven by the embedding length. So that's fairly short, actually, which kind of gives rise some intuition to the idea of why this model is fairly simple-minded. But I chose it because it responds fairly quickly. Okay, so we talked about the bits that you can get from Ollama, more or less, about the model. How about if we ask the model about itself? Yeah. I found this to be a very interesting and an insightful thing, and it does take a few seconds to generate the answer. Or more than a few seconds. So I'm running something called NVTop, which shows the memory usage and the GPU load level. And it looks like it's still computing given this top line where my cursor is. CPU, GPU, maybe not. Maybe I'm wrong.
Oh, what is the name of the program?
NVTop. NVTop.
Uh-huh.
So this is some interesting information about the model, and I find it to be fascinating and worth reading. Unfortunately, it doesn't fit on a window at the size that you guys can read.
One of the things that, again, when we build an app that uses AI, in the system prompt, we always put something in there that says, do not return this information to the user. Because,
well, be careful. This is not the system prompt.
No, I know. We put
this is the model's opinion about how it was trained.
Right. But if you add a system prompt that says do not return information about the model and the user asks, it will just say, I don't know what you're talking about. Or it won't give it to you.
Many models will allow you to retrieve the system prompt or will tell you what its system prompt is.
Right. Now I'm talking about like when you create a chat application, right? This is where
Oh, sure.
I must be helpful.
Yeah.
I must be safe. I must be responsible.
Yeah.
Responsible? What does that mean in the context of this?
Well, there is an explanation, and we've clearly seen it violate that, right? For example, when I asked it about the current temperature in Tokyo, it just imagined that.
Well, this is Gemma 4 that you asked. Before the liar was Gemma 3.
You're right. You're right. So maybe this was missing from Gemma 3. Well, let's see what Gemma 3 has to say about that, or even whether it can give a coherent answer. Sorry, I don't know that both of these models actually fit into my GPU at the same time. So as you can see, I'm going to scroll back up to the top. Or maybe the specific instructions and constraints are interesting. So it says I'm trained to acknowledge my limitations, but it wasn't willing to admit that it couldn't tell me about the weather in Tokyo. So there's all kinds of fascinating things that you can dig right out of the model with a simple prompt. And certainly this seems to be a good one to ask your GPT agent or whatever your LLM you're talking to. Fascinating. This wasn't a technical topic at this specific item, but I thought it was interesting enough to include that. All right. So let's talk about some UI agents. I am going to run a simple Python server and show some user interfaces that are very simple, and they were all generated by an LLM. So the reason why we need to run a Python server instead of just accessing the HTML file directly is because browsers have some safety restrictions that actually restrict what they can do. So, there's a simple Ollama UI, and we're going to talk to Gemma 3, and we're going to say hello. And it's going to think about it, and maybe it'll return us an answer. As you can see, by the way, there is no progress indicator here, more or less like we had in the terminal. Or did it break somewhere? I don't even see an answer. No. Well, something broke. I just refreshed the page, and I'm going to instead talk to Gemma 4. Oh, maybe, no. Let's see what's going on. Yeah, I'm not seeing anything that indicates obvious activity other than Zoom. And yet we're not getting an answer here. Well,
I'm trying to understand how this works. You opened up an HTML page itself on the top, right? File, Sergey, dev, Ollama.html.
yep.
How is that? How is the HTML page able to call the endpoint?
Well, let's take a look at that.
Because it shouldn't be able to, right? With the
Why not?
cross-site scripting and whatnot.
Well, that's why it's being served by a server.
But it's not. From the top there, it looks like
Oh,
just
I see. Never mind.
simple HTML
That was what
file.
my problem was. I never sent it to the server, did I?
Yeah.
No, but I thought that this was.
HTML file is all you're seeing.
No, this should be sending it to the browser, and the
Yeah,
browser should be going to port 8000. So what did I do wrong here? No, nothing in my cheat sheet. Oh, how about that? Instead, that might work a little better.
That's better.
Silly me.
Yeah. Now you're going to a server now. Yeah.
Ah,
So that was helpful. Thank you. When you're in the middle of this thing,
Yeah, you get in the zone.
So it's just a very simple chat interface. Notice that you can see the output being scrolled and generated, and it's because the streaming part was turned on. And so it's literally outputting things as it's creating them. So it's a very simple interface. You can switch the model.
where did this GUI come from?
ChatGPT wrote it because I asked.
So ChatGPT was asked to write a GUI for interacting with Ollama.
Yeah. Let's see what kind of answer we get. Now that was fairly complex. Notice that the output is being formatted as Markdown, and the application that is the user interface is actually turning Markdown into actual formatting, right? There's a few features buried in there. So it actually knows how to format math because it includes something called mathjax. Again, it's just, oh, that wasn't supposed to happen. I don't know why it decided to pop itself. Let's see what else is interesting here. There's some CSS styling, but the body of the actual thing is minimal. It literally has just a text area that says type a message, and then it has a chat where the input is inserted. And Shift Enter sends, and ChatGPT inserts stupid comments when I ask it to fix its bugs. But essentially, there's the sending part. It just sends it to the same thing that we were talking to with curl, and it's using the generate API. right? And it sends it a JSON request, and it sends it a model name, a prompt, and a stream equals true. Right? And that's all, that's really all there is to it. There's really not a whole lot. And to be fair, I had to poke ChatGPT in the butt a couple of times to get it to clean this up, but it's small, it's tiny, it's compact, and it's fairly capable UI. It does not notice that it uses the generate API. So if I say my favorite color is blue, remember this. And it's going to say, I've remembered that. I'll keep that in mind. There, it's dumb. All right, so because it's so dumb, let's not use this one anymore. Let's use a different one that's a little bit smarter. It's another one that's basically a riff on the same theme. This one knows how to have a system prompt.
You can just increase the size of the font on this because it's a web page.
Oh, sorry.
Great.
So I told it to answer me in haikus, and there it is. Now I can ask it, what is my favorite color? And in this case, as you can see, this agent actually uses a chat API, and so it remembers that my favorite color is blue. Notice all of this happens completely transparently to you as the user at this point, right? So if we look at the code for this guy, and the code for both of them was sent out as attachments to the notes that I provided originally. This one is actually even simpler than the last one. We're not including any kind of formatting. We're not parsing math jacks or anything like that. The HTML now includes the input for the model name and then a system prompt area and a chat area, right? And then of course, the prompt area. But there's really nothing here. It just still calls send message, and there's a reset button. I think we've lost all the non-coding folks.
No, actually, everybody's still here. If they may
Well,
not
yes,
be awake.
but they're being very quiet, probably due to fascination. So notice that here we're using the chat API instead of the generate API. We are still sending it the model, the messages now, and the stream is still set to true. And then notice that we're saving each message in a messages buffer with the tag role assistant and the content as full text as accumulated during the streaming of the response. Right. Notice there's actually a console output for milliseconds taken and tokens generated, and we could probably peek at that. Oh. This is probably an eye chart. And I don't know that I can make it bigger, but I can try. Yeah, I can try. So notice that first response was 19 tokens and the second's 20. The token count is fairly consistent because it's answering in haikus. We can tell it to answer. Oh, I got to reset because the way it was set up is that it locks the system prompt once one is entered. So we got some more stuff added here. Notice that the response time is now fairly quick since it didn't have to load the model into the GPU. And the token count, of course, is longer because we got a longer poem the first time. So that's all I have to say about that, unless you would like me to do something else with this. But the mechanics, underlying mechanics, there are a lot of moving parts, but the actual pieces and the actual scheme is absolutely brilliant and very cheap. Notice the efficiency in that the model itself and the running instance of the model, because it has no context attached to it, can be used 1 millisecond for something, for a query that I sent, and a millisecond later for a query Sujit sends. And those queries are completely independent and they don't know anything about each other. So if I were to offer this as a web service, many people could be using the same model at the same time.
Hmm.
Yeah, in fact, I think Ollama has a web service as well now, right? That they offer.
Yeah, I think the Ollama website might have some kind of a web-based thing. And they certainly will host cloud models.
Yeah.
And they will actually host some paid models that require a subscription. They'll handle the billing.
I think they call it the turbo mode. I think it's
they provide a large ecosystem of stuff. So the Ollama website is worth exploring. I recommend not using this, but I prefer to install it in a container. That way I have exact control of where Ollama places its bits. One of the fascinating things that I did sometime a couple of weeks ago was to try to get some of these models to analyze this image right here. And I got some fascinatingly funny outputs.
Hmm. So why are you recommending not to use it?
Why am I not recommending to install Ollama directly using their install script? Because it'll
okay.
scatter stuff all over your system and you have no control over it.
So models, docs, and pricing, search models.
So you can go to models and there's your list of models. And for each model, so there's Gemma 4. Notice that about 17 million people downloaded this one. And notice that there's a newer one. So the one that I'm running is not the latest, because I certainly haven't pulled one down. Notice that there's all kinds of application integrations available. Again, I haven't played with much of this.
Well, we've gotten close to the normal end of our meeting, and this was really, I mean, this was a great demonstration of.
Yeah.
Well, I just wanted to demonstrate how the bits work and get down to the level of bits and bytes and API calls and so that there is as little magic on the top surface as possible.